Hello and welcome students. My name is Shampa. Today we are going to study negative integral exponents. Now what do we understand by negative integral exponents? In our last session, we studied about exponents where the exponent part used to be a whole number. The exponent part, normally it's a natural number, but in some cases the exponent part is 0, and we know whenever there is a base and the exponent is 0, the result is 1. So far we know. But now, what if the exponent is negative? Let's understand. Say a is the base and minus n is the exponent. In that case, we will simply take the reciprocal of the base, and this will be, this 1 by a will have n as the positive exponent. Let's understand it with the help of an example. Let's say we have 7 raised to the power minus 2. So what we are going to do is this. We will take the reciprocal of the base. So the reciprocal of the base is 1 by 7, and now the exponent part will become positive. And this exponent part will be shared by the numerator as well as the denominator. Let's understand it with the help of some more examples. See, we have 2 raised to the power minus 4. What are we going to do in this case? Let's take the reciprocal of the base. And this way, the exponent will become positive. And we will embrace the reciprocal with the small bracket, and we will put the positive exponent here. So let's solve it. 1 raised to the power 4 is nothing but 1. 2 raised to the power 4 is 16. So 2 raised to the power minus 4 is 1 by 16. Let's do one more. 7 raised to the power minus 3. So it's going to be 1 by 7, and the exponent will become positive here. 1 raised to the power 3 is nothing but 1, and 7 raised to the power 3 is 343. Simple. Now we have 5 raised to the power minus 4. Let's take the reciprocal of the base first, and then the exponent will become positive. So it is 1 by 625. See, that's so simple and so easy. We have 10 raised to the power minus 15. Take the reciprocal of the base and embrace it with small bracket, and then the exponent becomes positive. So this is, it's going to be a big number, so we can leave it like this. We can leave it at this stage. It's not a problem. We can leave it like this. Now we have this number, 2 by 3 raised to the power minus 3. What are we going to do in this case? Again, let's take the reciprocal of the base. We have 3 by 2, and the exponent will become positive. See, we have 2 by 3 raised to the power minus 3 and 3 by 2 raised to the power 3. They are the same. There's no difference. They are the same. It's only that we made the exponent positive. Now we can solve it. 3 raised to the power 3 is 27, and 2 raised to the power 3 is 8. So 2 raised to the power minus 3 is 27 by 8. Now let's work on some more examples. Just now we did a question like this. 5 by 7 raised to the power minus 2. We just learned whenever there is an exponent which is negative, we take the reciprocal of the base and the exponent becomes positive. So it becomes 7 by 5 raised to the power 2. And now we can put the exponent on 7 and 5 separately. This is going to be 49 by 25. This is actually the sixth law of exponents. So far, we have studied 5 laws of exponents. This one is the sixth law. Come on, let's work on some more examples. Let's say we have 1 by 4 raised to the power minus 2. And we have 1 by 2 raised to the power minus 2 again. Let's add 1 by 3 raised to the power minus 2. What are we to do in this case? It's easy. Take the reciprocal of 1 by 4, it's going to be 4. And the exponent will become positive. Take the reciprocal of 1 by 2, it is 2. And the exponent will become positive again. And take the reciprocal of 1 by 3, it's going to be 3. And the reciprocal will become positive again. So 4 raised to the power 2 is 16 plus 4 plus 9. So it's going to be 29. See, it was that simple. Let's take one more example. We have 6 to the power minus 1 plus 3 by 2 raised to the power minus 1. Embrace it with the big bracket and we have minus 1 on the whole. So, in this case, we will solve it. We will solve the stuff that is inside the bracket. So, let's start working. 6 raised to power minus 1 is, you guessed it right, 1 by 6. Plus, take the reciprocal of 3 by 2 because there is another negative exponent here and we want to get rid of it. So, we have 2 by 3 raised to the power 1, which is nothing but 2 by 3. And this whole is raised to the power minus 1. For the time being, just ignore this exponent part. We will deal with it later. Now, this is nothing but an addition of two rational numbers. I'm sorry, this is 2 by 3. We know how to deal with it. So, this is going to be 1 by 6 plus 4 by 6 raised to the power minus 1. So this is going to be 5 by 6 raised to the power minus 1, which is going to be 6 by 5. That was also simple. Let's move on to our next section. So we have 2 raised to power minus 1 plus 3 raised to power minus 1 whole square. Let's work it out. 2 raised to the power, let's work on the stuff that is inside the bracket. 2 raised to power minus 1 is 1 by 2 and 3 raised to power minus 1 is 1 by 3. We know that. We just learned about the how to deal with the negative integral part of the exponent. So now we are going to add these two rational numbers. It's very simple. So it's going to be 5 by 6 whole square, which is 25 by 36. Let's move on to this part. Again, we have, it's a subtraction inside the bracket, but it's not complicated. So we have 2 by 4 minus 1 by 4 whole square. And we have which is 1 by 16. That was easy. Now, let's do this part. It seems complicated, but let me assure you it is not. Let's work on the stuff that is inside the bracket. 3 by 4 raised to the power minus 1. We can write it as 4 by 3 raised to the power 1. It is the same thing. Minus 4 by 1 is nothing but 1 by 4 is nothing but 4. Reciprocal of 1 by 4 is nothing but 4 raised to the power 1, and embrace it with the big bracket and leave this minus 1 for the time being. We will work on it later. Okay, and now we have 4 by 3 minus 4 raised to the power minus 1. Let's work it out. And we have minus 8 by 3 raised to the power minus 1. Now let's take the reciprocal because we don't want this negative exponent, right? So the reciprocal is minus 3 by 8. That's the answer. So this was also easy. Let's move on to our last section. Now this is our question. There's a number minus 8 raised to the power minus 1. To which number can we multiply this minus 8 raised to the power minus 1 so that the product becomes 10 to the power minus 1? Okay, as usual, as we know, let's take let x be the number, x be the unknown. And now we have to multiply minus 8 raised to the power minus 1 with x, and the result will become 10 to the power minus 1. We don't have to worry at all. We are going to do it normally. What we are going to do? We will take the reciprocal. This will become minus 1 by 8 into x, and this will become 1 by 10. So let's work it out. We have x equal to 1 by 10 divided by minus 1 by 8. We know the rule that when this number was sharing the relationship of multiplication with x, it went to the other side and multiplication becomes division whenever we change the side in a linear equation. We have 1 by 10 multiplied by minus 8. Because there was a division sign and we wanted to solve it, so we converted the division sign into multiplication sign, and whenever we do that, we take the reciprocal of the divisor. We know that. So this is going to be minus 4 by 5. This was easy. So that's it for today's session. We will do few more examples on exponents in order to make the concept clear. Till then, please take care of yourself and you have a good day.